Well, so plowing it under is part of the process, but what's so good about it is everything it contains and the nutritional value. We think about we put fertilizers in to grow a good, healthy crop. What do we remove? The grain. But about just under half, over half that crop goes out the back end of the combine. And there's some nutrition in there as well. And so that's kind of the question. Can we access that nutrition? And the way I would phrase it is, can we use that fertilizer nutrient twice and get it to release a second time for next year's crop?
So how do we measure this? I'm not sure that that's going to be easily done.
No, it's not. The first thing you can look at is yield. And if you see a yield return to whatever you're managing, you could assume came from the residue. We can do residue decomposition studies, a lot of no-till, where we sample the residues, put them out over the winter, sample them again in the spring, and say how much weight did they lose. And hopefully where we're doing different treatments, they lost a little more. I am excited. There's a research project working with Dr. Andrew Margonaut at the University of Illinois, where he and I are going to work tracking that nutrition through the residue and see how much does release for the next year's crop. But stay tuned for that one. That one's just getting started. So
what did you pitch to the fertilizer applicators here?
So when we think about where the future of crop production is going, higher residue scenarios are going to be a guarantee. Whether there's increased in conservation tillage, such as strip till or no-till, or cover cropping, or just simply higher yields. Higher yields also come with more residue. So it's now something that residue, as good as it is with all the nutrition in it, it can become a problem for next year's crop, inducing yield losses because it ties up nitrogen and it can make it hard to get the planter through. So we have to manage our residue, and that's what we wanted to talk about today.
How do we manage this residue?
So there's three broad approaches. There's mechanical, chopping the residues up, either on the combine or some sort of post-harvest equipment that you run across. It's just like when we chew our food. Makes it more digestible, more surface area. The microbes can break it down more quickly. The other side is what we would say chemical, using fertility. Microbes like nutrients just as well as plants do, and so maybe a little bit of nutrition can help stimulate them to go after that residue. I would like to phrase it, it's like putting some salt and pepper on the steak, season it a little bit, make it a little more palatable for the microbes. And the new area is the biological component. We know that biology in our soils does the residue decomposition, but now there's a new product market where you spray microbes on the residues to try and get them degrade more quickly than they might naturally. So mechanical, chemical, or biological approaches to manage the residue.
Farmers, I don't think, they know about the biology in there, but how just spraying some biologicals on there, do we know how to measure that? Do we know how much to put on? That would seem to be a head scratcher.
And it still is a head scratcher. For those that follow the policy and regulation behind this product sector, there really isn't much. So there's a lot of variability in the options farmers have. A lot of products are out there, and every company formulates different ways. Different microbes in the mix, different number of microbes, and different spray rates. So there's a long way to go on that. But from a end user perspective, when we're doing trials or looking at things, we can just focus on the agronomics. When we do add a product or a practice to the system, is there a yield benefit? And then if so, that's great. We've got something. Then the hard part is figuring out why. But that's probably where we start. Put it out there, do a yield comparison, and see if there is an advantage. And then if there is, we got to just figure out what exactly is going on, and then maybe we can fine tune it even further.
It may take several years to figure out what the successful application rate and how we do it and what product to use.
Exactly. It's going to change farm to farm. What type of residue are you treating? Is it corn stalks, or are you following a cover crop? And what type of cover crop? Is it a rye cover crop or a clover cover crop? That might change what type of microbes you need to spray or how you spray them. So it's a really exciting space, but one that definitely we have a lot more questions than answers today. But certainly the biology, if you go to the textbook side, it makes sense. It pencils out, and so now we got to figure out how to make the textbook work in the field, and that's a whole different beast. But certainly an exciting spot to be working in and trying to get some answers. one big thing with the whole residue decomposition space, a lot of the story is if we're releasing the nutrition from our residues, we maybe don't need the fertilizer because we've accessed it some other way. And that might work for the first year, the second year, the third year, if we're really blessed, the fourth year. But keeping in mind, as we cycle those nutrients better and you get higher yields, every time that those grain trucks leave the field, nutrition's leaving the field as well. And so residue decomposition doesn't bring nutrients into the system. And so it's a step to manage the program, but it still has to be paired with proper fertility management as well. And so I think that's the biggest thing for those trying to do the residue side. It's more efficient cycling the nutrition, but we still have to make sure we provide the nutrition for it to cycle.